classroom in the U of M. I actually just stole one of their classrooms. They left it blank. They're probably going to come in like 10 minutes. So let's do a quick lecture on something I find pretty interesting, which are these things called vectors. They're very useful, especially when we get to, especially in physics. The unit we're doing right now in class is on magnetism, and vectors are super important because we talk about dot products and cross products, all of which we'll cover in the next days when I upload a video. Don't know when. All right, so let's start off with an introduction of a vector. So let's say that right now we have a point here, and this is the point A comma B. And then let's say we have another point in space, like maybe right here, and this is the point C comma D. These are all variables, doesn't matter what they could be. Then if I draw the arrow that starts from here, starts from this point, and it touches this point, drew it poorly. There. This is a vector that connects this point to this point. The way we write the equation for the vector is we just do the change in x, and then the change in x comma the change in y. The change in y. So how we would write that in this case would just be the change in x, which is c minus a, comma the change in y, which is d minus b. There is our equation for a vector. All it is just an arrow that points from one thing to another thing. Let's just try an example. So let's say that instead of a comma b, we have points, like actual numbers, like maybe this is the origin, 0, 0, and this point is, let's say, like 2 comma 3. Right? The equation for this vector would be the change in x, so 2 minus 0, that's 0, comma the change in y, so 3 comma 0, that's 3. There's our equation for this vector. This vector right here. Make sure when you write vector notation, you have these nice arrows, because that symbolizes that this is in fact a vector. You can remember this because a vector starts with v, v's are pointing just like these things. Now let's say we have another point in space. Like up here, we have the point 4 comma 6. I'm going to move this up here so we don't run out of space. And we draw another vector from here to here. What's the equation for this vector? I'll call this A, I'll call this B. You put arrows on top of them to show that they're vectors. If this is vector B, the equation, again, is change in x, 4 minus 2, that's 2, and then the change in y, 6 minus 3, but that's 3. It's the same as vector A. Like, it has the same equation, it has like the same notation, we wrote it the same way. What this actually means is that these two vectors are the same thing, which is something special about vectors. Like, if you have a point, and I move the point, I have a different point. But if I have a vector, and I move the vector, it's still a vector. So now we get to the two properties of vectors. One is the direction it points. If I have a vector that points up, and a vector that points to the right, these are different vectors because they point in a different direction. However, these two vectors are pointing in the same direction. Another thing, so I'll write this down, properties of vectors. We have direction. And the second thing is something called magnitude, which is a little more complicated. Oh, shoot. Magnitude. Magnitude is actually just the size of the vector. Like if I have a vector that's like this big, and I have another vector that points in the same direction, but is this big, these are different vectors because this one's bigger than this one. However, if we look at these two vectors, A and B, A is the same size as B. So these are identical vectors because their direction and their magnitudes are identical. All right. So that was a brief introduction of vectors. Final thing we'll cover is how to find the magnitude of a vector itself. The magnitude is actually the same as if you wanted to find a distance between the 2 points, from the tail of the vector to the head of the vector. These are the terms that define, like, tail is the one without the arrow, head is the one with the arrow. The magnitude of the vector is actually just found using the Pythagorean Theorem. So what we can do is we can just say, here's a point, this is the point 0, 2, or no, 2, 0. Here's the point 2, 0. Right? So the distance from here to here, we can clearly count is just 2 because we just go 2 steps to the right. Then distance from here to here is 3 because we go up 3 up, or we go up by 3. So the distance from here to here, if we use the Pythagorean Theorem, is the square root of 2 squared plus 3 squared, or equal to the root of 13. that means the magnitude of A is root 13. The way we write that is we draw the line like this, like the absolute value symbol, and then we say that this is equal to the square root of 13. And that's our vector's magnitude. This is really important when we get to dot product, which is the next video, if I upload anytime soon. All right.